In today's episode, recapping day 3 at IBM Think, two major things that really stood out from the day. There was a ton of good stuff. One of the things I really enjoy about this show is being able to walk up to people who are senior or master level data scientists and machine learning experts and ask them questions like, hey, can you take a look at this code that I'm working on? And have them go, oh, well, that's not how I do that. And get productive feedback about ways you can improve your own code. So that's been a lot of fun. But there were two initiatives that I thought were super important. One is called Fairness 360, and one is called Watson OpenScale. When it comes to bias in our data, we've talked a lot about this. You've heard a lot about this um, in the news, in major stories about companies, big companies like Amazon getting in trouble for having biased data, biased AI, causing problems in hiring and discriminating against certain groups. And a story I tell from one of my keynote talks is police department trying to predict recidivism and failing miserably at it because of bias. There are three places that bias can exist in the path towards AI. You can have bias in the data, where as you're collecting the data, it itself is biased, and that it wasn't collected properly. There was data missing, or in many cases, there are problems in the population data itself. The example I cite often is African American healthcare data is inherently biased and flawed because of systemic discrimination within the society itself. So that's one place bias can occur. The second place bias can occur is in the model creation. When you're creating an AI model, which means that the software is taking the data and learning from it, the software can create biases. A simple example, again, it's sort of a hiring example. Even if you say, I don't want to use gender or age. If you had things like someone's Facebook movies that they like and books and music that they listen to, you can infer with a high degree of accuracy a person's age and gender and even ethnicity. And so you can create a model that has bias in it. And then the third place that a bias can occur is even if you've done a good job with the data and you've done a good job with creating the model. The third place it can occur is in production when you deploy the model and then new data starts coming in because you've built it, trained it, and now it's in production. Bias can happen after the model has been deployed because you can get unforeseen data or unusual data that you didn't expect to get. The classic example of this is when Microsoft released its Tay Twitter bot, and people fed it new, highly corrupted data from the perspective of the things you'd want to talk to a robot about and turn it to a racist pornographic bot in 24 hours. Thank you, humanity. And so these are the sort of the three places bias can occur. Now, mitigating bias means taking all three places and trying to put safeguards in place for them. So two of the announcements that IBM made at the show and have deployed product for that I thought was really interesting. One is called Fairness 360. This is an open source, totally free set of 10 Python libraries or Python algorithms that you apply to the data side. And it will look at your data and say, there are problems in the data. There are populations that are underrepresented. You specify, like, I want to make sure that say we're doing a test on gender. It will look at it and say, hey, I think that there's an issue here. Gender is underrepresented by this, or race is underrepresented by this. You would specify protected classes, and then it would notify you that there are significant problems. You can do a lot of that manually with various machine learning software, but having some prepackaged stuff that you can just put into your workflow and immediately get identifying is really, really powerful. The second place that you can mitigate bias is when you're doing things like feature selection in Watson Studio. Watson Studio, as you're building your models, you can identify like there's something wrong here. But the third one, and thing I think is probably the most powerful of the announced products, is one called Watson OpenScale. This is for managing the models when they are in production. and it is doing what is called perturbation testing, where it's constantly, sort of holding back certain data and swapping it in and out as the model's running, and identifying like, hey, things are starting to drift, or this model's starting to exhibit bias. And like Fairness 360, you specify protected classes. You say, gender must remain at a 50-50 split, plus or minus 1% each way. African American representation must remain at 17% plus or minus a certain guardrails, and it will either help you retune and fix the models, or in the worst case, just shut it down if a model goes completely off the guardrails. If you think about it, there is, with OpenScale, you're talking about essentially doing repairs on the car while you're driving it, right? Or repairing the plane while it's in flight. It's an extremely difficult thing to do, and the fact that it has bias detection and mitigation built into it, so while you're managing your models in production, is really an incredible engineering feat to be able to say, like, yeah, we can fix the model while it's in production, not have to pull it down, and not have to wait for the next round of retuning, because OpenScale will help you tune it and fix it, even if you didn't intend in the original deployment of the model to have it be tuned in production. So super interesting and important product announcement and deployment. There is not enough thought being given in the machine learning world to the mitigation of bias. It is not a part of the average checklist for when someone is putting together what they want the software to do. And so having these tools be available within a production environment, and having, in some cases, like with OpenScale, having it be baked in so that you can't not have bias detection is really important. It's really important. It's really powerful to help make sure that AI serves the outcomes that we want to achieve. The third thing about OpenScale's bias detection that I thought was really interesting was that it prohibits or reduces inferred variable bias. So you may say, going back to the example from earlier, I want to not use gender, but if your model puts together an inferred variable of, like, between music and book and movie likes, you have a problem. You're still effectively creating a gender variable. When you have protected classes in OpenScale, and you say gender is protected, this is the outcome. Even if the model creates that inferred variable, it is still being held on course, like holding the steering wheel so that the car doesn't drift, by those protected classes. So you would say race and gender and age are protected classes, and no matter what the model comes up with to mix and match in those inferred variables, it still cannot say, okay, I'm going to now start discriminating against using this inferred variable, because it's over here, it's saying, nope, gender still has to say 50-50. Well, what about this? Nope, gender still has to say 50-50. And that is also really, really powerful. It's something, again, if you build a model and you're not thinking about bias, OpenScale is sort of the backstop to prevent you from going off the rails and doing something you didn't intend to do, and then waking up one day and going, oh my God, our HR system discriminates against women. So really, really useful stuff. Take a look. You can see Watson OpenScale on the IBM website, and you can actually try it out. There's a light version if you want to try it out with your models. They do have to be in production through one of many machine learning systems that actually deployed. So really cool stuff. If you have any questions, leave them below. As always, please subscribe to the newsletter and the YouTube channel, and I'll talk to you soon.
Want help solving your company's data analytics and digital marketing problems? Visit trustinsights.ai today and let us know how we can help you.